Hey everyone, welcome to the first video in our series on the reactions of chapter 10. In this video, we're going to be worried about synthesizing alcohols, okay? And I'm going to be splitting this up into 4 videos for chapter 10, but I'm going to be talking about multiple different reactions in each video, but I'm going to focus each video on a specific reagent, okay? So in this first video, I'm going to be worried about reagents that are known as Grignard reagents, okay? And then I'm going to be worried about some other reagents in other videos. So Grignard reagents are what we're worried about here, okay? So the first question is, how do we make a Grignard? So formation of a Grignard. So how do we get a Grignard reagent? So what we do is we take some alkyl halide. So we'll take this alkyl halide here. Bromine, chlorine, iodine, any of those work. And then I add in magnesium with ether as a solvent, or THF. And then that gives me a magnesium that inserts itself between the bromine and this bond, okay? So this is my Grignard. So this is a organomagnesium halide, all right? So Grignard reagent. And this acts as a carbanion, okay? So what that means is that it's a good base and it's also a good nucleophile. So this and this are the exact same thing, right? That's what this is acting as. It's acting as a negatively charged carbon. Okay, so that's what this is acting as. So that's why this is a good nucleophile, right? And so let me also say that we can just do this with anything, right? We can do it with something that looks like this. We can take this and any alkyl halide, just throw in magnesium and ether, and boom, we get our Grignard, all right? So anything like this, we can form a Grignard out of it, okay? So now what we need to do is we need to look at the kinds of reactions that we can have with Grignard reagents. All right, so let's look at reactions. So if you remember the very last video from chapter 9, we talked about terminal acetylides and their reactions with carbonyl groups. Okay, this is very, very similar. All right. So if I take some Grignard, so I'm going to take this Grignard here that I've already made on the left. And as a first step, I'm going to throw in a ketone. And then as a second step, I'm going to throw in some acid. So again, in that very last video on the reactions of chapter 9, we said that whenever we add a terminal acetylide to a carbonyl group, we turn the carbonyl group into an alcohol, and then we just add whatever our acetylide was. Well, in this case, we do the same thing. So what I'm going to do is I'm going to turn the carbonyl group into an alcohol, and then add whatever my Grignard is. So in this case, my Grignard is 1, 2, 3 carbons. So I add 1, 2, 3 carbons. I'm done. That's it. Okay. So very simple. All right. This is what it looks like with a ketone. With an aldehyde, it looks very similar. All right. So, but the other thing that I can do is if I can start with an alkyl halide, basically. And as a first step, I can throw in magnesium in ether. And then as a second step, I can throw in some aldehyde, right? So let's throw in this aldehyde. Okay. And then as a last step, I can throw in H3O plus. Okay. So now what happens? So this Mg ether is going to turn this into MgCl, right? Which is going to give me a Grignard. So that the first step is just forming my Grignard. The second step, so I need to take my carbonyl group and turn it into an alcohol. And then I just add whatever my group of my Grignard is going to be, which is going to be this phenyl group. So then I just add a phenyl group to this. And I'm done. Okay, so you'll notice that here I have a 3-degree alcohol. So a ketone becomes a 3-degree alcohol. And here, this is an aldehyde. This is a 2-degree alcohol. So an aldehyde becomes a 2-degree alcohol. All right. So ketone, 3-degree alcohol, aldehyde, 2-degree alcohol. That's kind of a way that we can kind of check that our product is correct, right? It's a good way to think about it. Okay, so I think we could do one more here. I think that one important thing would be that we can also react this with formaldehyde, okay? So in this case, I'm going to use, I don't know. I'm already going to have the Grignard made in this case. So now I'm going to throw in formaldehyde, which is this. And then I'm going to throw in some acid. Okay. So what's going to happen is all I'm doing is taking this formaldehyde, turning it into an OH, and then adding these 3 carbons. So these 3 carbons. But look at this though. 1, 2, 3, 4, and then the alcohol. These are just 2 hydrogens. I don't need to draw these in line angle, right? So what I actually have here is just this, right? These are the same thing. So right now, all I have is that. So what I'm going to do is I'm just going to erase this. And I just have this, okay? So this is my product, okay, right there. So let me redraw it over here so it's a little bit more clear. That's the product. And so in this case, whenever I use formaldehyde and only formaldehyde, I get a 1-degree alcohol, all right? So formaldehyde becomes a 1-degree alcohol. Okay, so ketone becomes 3-degree, aldehyde becomes 2-degree, and formaldehyde becomes a 1-degree alcohol. Excuse me. So these are my reactions for Grignards. There are 2 caveats for this, all right? So we'll discuss those next. Okay, so we're still in reactions for Grignards. All right, so far I've seen that I can add a Grignard to a ketone to get a 3-degree alcohol, an aldehyde to get a 2-degree, and formaldehyde to get 1. I can also add a Grignard to a acid chloride or an ester. All right, so in this case, what I'm going to do is I'm going to take an acid chloride here. So this is an acid chloride. Okay, and acid chlorides are just a carbonyl group that have a chloride on them. All right. And as a first step, I'm going to throw in some Grignards. So let's say CH3CH2 MgBr in ether. And then as a second step, I'm going to throw in H3O plus. Okay. And as in my first step, I need to have 2 equivalents of, let me just erase this so I can write this a little bit more clearly. So my first step, I need to have 2 equivalents of this, and we'll see why in a second. So with an acid chloride, all right, a Grignard will add twice. Okay, so in the reactions we've already seen, the Grignard adds 1 time, right? In this case, it does not add 1 time, it adds 2 times. Okay, so it's going to add 2 times. So that means that whatever my Grignard is, so it's CH3CH2, so it's an ethyl group, right? I'm going to get rid of chlorine, and I'm going to turn this into an alcohol. So let's do that first. So chlorine is gone, and I turn this into an alcohol, and then I just add my 2 ethyl groups. 1, 2, 1, 2. I'm done. This is my product for an acid chloride. All right. So you'll see that this is a 3 degree. So acid chloride becomes a 3 degree alcohol. All right. Acid chlorides become a 3 degree alcohol. Let's look at a different acid chloride. Let's look at this one. And then as a first step, we'll throw in 2 equivalents. 2 equivalents of phenyl magnesium bromide in ether. And then as a second step, we'll throw in some acid. Okay, again, so this is just going to be very similar. I'm going to turn this into an OH, get rid of chlorine, and then add 2 of whatever my Grignard is. In this case, it's a pH, right? Phenyl. So I add 2 phenyl groups. So phenyl is just a benzene ring. So I add 2 benzene rings. And that's it. Okay, so acid chlorides become 3 degree alcohols. All right. There's one other thing that becomes a 3 degree alcohol that I can add twice to, and that is a ester. All right, so let's take a look at a ester. So spoiler alert, like I said, esters become 3 degree alcohols with Grignards. And just add 2 equivalents of CH3 MgBr and ether. And then as a second step, I'm going to throw in some H3O plus. So in this case, I get rid of this OCH3. So just like I got rid of Cl, I get rid of the other group on the ester. And then I turn the carbonyl into an OH. And then I just need to add 2 of my Grignard. So in this case, my Grignard is just this methyl group. So I add 2 methyl groups. So I'm done. So I get terbutanol in this case. All right. So that's all I get. All right. So esters also become 3 degree alcohols. All right. Okay. So now that we've discussed that, right? So we've talked about ketone, aldehyde, ester, acid chloride, formaldehyde, all of those. Let's look at the mechanism. Because this is important. I'm going to do 2 mechanisms. All right. The first mechanism is going to be this one. So we're going to take acetone with, as a first step, CH3 MgBr. And then as a second step, we're going to throw in some acid. Okay. So what this is going to give me, again, I turn my carbonyl group into an OH, and then I add CH3. So I get this. All right. So ketone becomes 3 degree alcohol. So let's take a look at the mechanism. So I have this ketone starting off, and then I have CH3 MgBr. Okay, so this is a CH3. Okay, so this bond is going to attack this carbonyl because it's slightly positive, right? We've talked about this a lot before. And then those electrons are that bond is going to break, and those electrons are going to go onto that oxygen. So now this oxygen has a negative charge. And then I've added this, right? And this negative charge is counterbalanced by MgBr, which has a positive charge, okay? So MgBr has a positive charge. Okay. So now what's going to happen is, as a second step, I throw in some acid, right? So if I have that as my intermediate, then I throw in some acid. So I throw in some H3O plus. And what that does is I still have this. The acid is going to protonate the alcohol, or protonate the oxygen to an alcohol, excuse me. So I just get this, and I get water. And then I get MgBr plus, right? But that's it. Okay. So that's my mechanism for this first one. All right. So that's what happens whenever I add once. And the mechanism for a ketone and aldehyde is the same. So now let's take a look at the mechanism whenever I add twice. So let's do this one. And then we're going to add two equivalents of CH3, CH2 MgBr. And as a second step, we're going to throw in some acid. And then remember, I turn my alcohol or my carbonyl group into an alcohol, get rid of chlorine, and then add two of my Grignards. So two ethyl groups in this case, CH3, CH2. All right, let's take a look at this mechanism. So this one's a little bit more in depth. All right, so we'll cover it though. Okay. So what happens is, again, my MgBr, this bond between the MgBr is going to attack there, and that's going to break. So then that's going to give me this O minus with MgBr plus. Okay. And then I add an ethyl group, right? So now what can happen is, since chlorine is a good leaving group, this carbonyl is going to reform. All right, so those electrons are going to reform that carbonyl double bond, which is going to give this carbon in the middle 5 bonds. That carbon can't have 5 bonds, so a bond has to break. So chlorine is going to leave. All right, chlorine is going to leave. So then that's going to give me this ketone. All right. And it also gives me MgBr is going to get a Cl. So I'm going to get MgBrCl. Then I have this ketone. So now a ketone, remember, ketone's going to get attacked by Grignards. So another Grignard is going to come in and it's going to attack this ketone, right? And then that's going to form this same intermediate, this O minus, right? And I add my 2 carbons. Or that's MgBr, sorry. So my MgBr there, right? So now this can't reform, okay? This can't reform because there's no good leaving groups. So now what's going to happen is I'm just going to throw in some acid, okay? So acid is going to come in again. And it's going to protonate that O to give me the alcohol. So I get water, and I also get MgBr plus. Which will eventually go off in complex with something else. All right. So this is a pretty important mechanism, especially the second one here. So I would definitely study up on this one. Whenever it comes to the mechanism with esters, it's the same thing. Okay. So instead of the chlorine leaving, the OCH3 or the O whatever is in the ester would leave. Okay. And that would be the leaving group. All right. So that's it. Nothing else with that one. Okay. So this is pretty much everything with Grignards. On the next video, we're going to talk about organolithiums, which are basically the same thing as Grignards. They are just formed a little bit differently. Other than that, they do the same types of reactions. Okay. So we'll discuss those in the next video. So I hope this video was helpful, and hopefully I will see you in the next one.